We're back at Honors Algebra 2 Pre-Calculus doing section 9.2 from Pre-Calc, which is arithmetic sequences and partial sums. So we're going to start on page 625 in your textbook with the definition of an arithmetic sequence. So a quick note, arithmetic, right? Arithmetic is a thing, right? It means like adding and subtracting, right? It's the simple math that you learn when you're in elementary school, right? Arithmetic is an adjective describing a type of sequence or series or whatever, right? So arithmetic, noun, it's a thing. Arithmetic is how we say the adjective. So just to clear that up so that we understand that I'm not saying a weird, like a word that you already know in a weird way. I'm saying a different word. It's arithmetic. Okay. So for example, if I have a sequence, a sub 1, a sub 2, a sub 3, a sub 4, all the way up to a sub n, right? That sequence is arithmetic if the difference, which we're going to call d, between the consecutive terms is constant. So that is that if I took whatever a2 is minus a1, so a2 minus a1, I'd get a number, right? If I took a3 minus a2, I'd get the same number, d. If I took a4 minus a3, I'd get the same number. In fact, if I took the nth term minus the term before it, which would be a sub n minus 1, I'd get that same constant d, right? So d is called the common difference. To show you an example, and then we're actually going to go through an example, but just to show you one sequence that is arithmetic and one that is not. So the sequence 1, 3, 5, 7, 9, dot, 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 is arithmetic. And not only is it arithmetic, but you can spot the common difference is 2, because what you'll notice is that to get from 1 to 3, I add 2. So 1 plus 2 gives me 3. 3 plus 2 gives me 5, right? 5 plus 2 gives me 7. 7 plus 2 gives me 9, right? So essentially what I'm doing is every single time to get from one term to the next, I'm adding that common difference d, which in this case is a plus 2, right? But the sequence 2, 4, 6, sorry, not 2, 4, 6, 8, that would be arithmetic. 2, 4, 8, 16, 32 is not arithmetic. Because to get from 2 to 4, I would add 2, but to get from 4 to 8, I'd have to add 4, right? Now, admittedly, someone is probably saying, but Hogan, you could just multiply by 2 every time, and then it would give you that sequence. And you're right, it would. But that's called a geometric sequence. So notice that when we're adding or subtracting a common difference, right? Adding or subtracting a common difference, that's called arithmetic. When we multiply by a common number, like we do in this sequence that we're going to deal with in 9.3, that's actually called geometric, and we're not there yet. That's in 9.3, and we're in 9.2. So again, this 1, 3, 5, 7, 9 is arithmetic because you're adding 2 between each consecutive term, right? But 2, 4, 8, 16, 32 is geometric because you're multiplying by 2, and we're going to talk about that in 9.3. I could also give you a sequence where the numbers are just a random assortment of numbers and are neither of those two kinds of sequences. Those are two special kinds of sequences. So we're going to walk through an example and identify a sequence as either arithmetic or not arithmetic for right now. So let's do an example 1. All right, so example 1, is it arithmetic? If yes, what is the difference, right? So what is that common difference, d, all right? So first sequence, we're going to do A, we'll do a B, we'll do a C, and we'll do a D. Okay, so let's do 500, 497, 494, 491, 480, each, dot, dot, dot. Okay, let's do 1, 4, 9, 16, 25. Let's do we'll do 1. Let's do 1/2 and 2. And 7 halves, and 5, and 13 halves. And let's do 1, 1, 2, 3, 5, 8. Okay, cool. So I just got some random sequences, some random, some not so random. Okay, so is it arithmetic? If so, what is the common difference? Okay, so remember that in order to find the common difference, we are adding or subtracting the same number to get to each subsequent term. So to get from 500 to 497, I say to myself, oh, I would subtract 3, right? 500 minus 3 would give me 497, and if I subtract 3 again, I'd get 494, and if I subtract 3 again, I'd get 491, and if I subtract 3 again, I'd get 488. So the answer is yes, and the common difference is negative 3, right? So the first one, the answer is yes, and the common difference is a negative 3, right? For the second one, to get from 1 to 4, I would add 3, right? And then to get from 4 to 9, I'd add 5. So right away, the answer is no, right? There is no common difference. Right away, I don't even have to go any farther than those first two. So this is not an arithmetic sequence, right? Now, again, just because something's not arithmetic doesn't mean it's not predictable. I know you could predict the next spot here. I know you'd see the 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Oh, hey, the next one's a 36. Just because something's not arithmetic doesn't mean it's not a predictable pattern. It just means, hey, you're not adding the same number every single time, right? And you can be adding a negative number every time, which is why it can come out as a negative value. So to do the next one, there's a couple different ways to look at it. You could either convert this to decimals, which I think makes it easier, or I would suggest that in this next one, it's easier to look at it instead as all fractions, right? So if I rewrite this, this is a 1/2, right? A 4 halves, a 7 halves, a 10 halves, and a 13 halves. What becomes clear when I rewrite it as all fractions is that I'm adding 3 halves every single time, right? There is a common difference. To get from 1/2 to 4 halves, I'm adding 3 halves, right? And then to get from 4 halves to 7 halves, I'm adding another 3 halves. And to get from 7 halves to 10 halves, I'm adding another 3 halves. And then to get from 10 halves to 13 halves, I'm adding another 3 halves. So the answer is that C is yes, and the common difference is a 3 halves. You could write positive 3 halves or just 3 halves because we assume that a number with no sign defaults to positive. And then the last sequence does not have a common difference, right? And you can see that because to get from 1 to 1, you'd add nothing, right? And if that continued, your sequence would literally just be all ones. 1, 1, 1, 1, 1. So, and then to get from 1 to 2, you add 1. Okay, so right away, that's a no. And it is worth noting that sequence D in example 1 is a fairly famous sequence. It's Fibonacci, right? We talked about that in the 9.1 videos when we talked about some sequences with recursive formulae. So anyway, that's example 1.